Good morning, good morning, good morning. Good morning, good morning, good morning. Anthony's wandering around. Did I just hear that correctly? I'm glad it does to one of us. Okay. What?
Yep.
Well, go down to the library and get a loaner.
No, I mean in my locker. Am I gonna be late if I go get it?
Well, you have to wait now for 10 minutes. Sorry. The one thing that you need to bring for class. That's it. The one thing. Good morning, ladies and gentlemen. How are we doing today? Good. Yes, good, good. Semi, partially, kind of. Don't you dare shake your head no.
I'm just saying. I'm
Okay, good. Nap time, 3:05 today. Meet in this room. Okay? 3:05 nap time in this room today. Okay? All right, but we can only do it for 10 minutes. Then you got to go. Okay? Short naps are better for you anyway. Okay? They say Einstein used to take like 5 short naps a day. Just means he didn't have a job, ladies and gentlemen, that he could take 5 naps a day. Anyway, ladies and gentlemen, all right, take out your computers, get logged in, let's get ready to go. Start thinking about this question. How do we find density? Density. What is density? How do we find it? What info do we need? And how do we measure it, ladies and gentlemen? Well, that's our question of the day. Let me get attendance, and then we will start talking about those things. All right, not here. Not here. Jacqueline is. Brenda's upstairs. Good, 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 good. Good, good, good. Jasmine, you're hiding back there. I think I see you. Good. Haley. All right. Cynthia and Nadia. Yes. Ashma Miro. All right. Brinley will hopefully come back at some point in time from getting her new computer. Okay. Boy, all she has to do is complain about her battery one day. She gets a new computer that same day. You guys got it good. You should just complain about your computers more often, ladies and gentlemen. All right, 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 16, good, that would work, that would work, that would work. Hey, electricity ain't free, you know. What?
You scare me.
How do I scare you?
Well, I mean, you say random stuff and I get shocked.
No, electricity ain't free.
It is though.
Are you shocked by that?
Good one.
Get it, get it, get it. What do you mean it's free?
Like it's free because like I don't have to pay for it.
Yes, the school does.
But like
That's like taking somebody else's car for a ride and saying, well, it's free because I don't have to pay for it because I stole it.
Yeah, like it's for them. Yeah.
She just agreed with that.
Yeah.
She agreed with that. It's
I
okay
mean,
to
that'd be
steal a
free
car.
for someone else, but it's free. Yeah, it's not my problem.
Actually, you know whose problem it is?
Who?
Your parents.
What about them though?
They pay for it.
Why is this electricity?
Well, who do you think pays the school's bills?
I didn't know that.
So, your parents trust me enough that they pay for me to teach you. Good morning. How we doing
I'm
today?
very upset because I tried to get here on time. My sister was out of the house by 7:10.
Wait, what? Run that by me again in slower motion.
I'm upset because my sister was supposed to be out of the house by 7:10, but she lost her lady or whatever, so I'm late.
So leave her. Leave her.
I said.
Just go without her. Hey, one person shouldn't make everybody late. If I'm being chased by a bear and my wife's running slower, sorry. Okay? Sorry. And she's probably going to run slower because I'm going to hit her in the knee real hard and I'm going to get away because you don't have to outrun the bear. You just got to outrun who you're with, ladies and gentlemen. That's the key. Don't try to outrun the bear, outrun who you're with. And if you hit anybody in the knee hard enough, you can outrun them. Just saying. Just saying. Okay? All right. So did that scare you?
Yeah. No,
Okay, good. All right, ladies and gentlemen. So just remember, don't be walking near me in the woods when a bear jumps out. Okay? Okay? Either that or get off to a good lead. Because if I can catch you, I'm hitting you in the knee.
I'm not a runner.
You're not a runner, me either. I run with a purpose. The purpose isn't being chased by somebody. That's what I run. Okay. All right, ladies and gentlemen. So, what do we need to find density? What is density? What?
Mass and volume.
Okay, we need mass and volume. Density is a combination of mass and volume. Do you know what density actually is?
The amount of
How
matter
dense
packed
something
into
is. Now, can we give that definition again without using the term we're trying to define in our definition?
the amount of matter packed into space.
Okay, the amount of matter packed into space, which is correct. It is how dense something is. But it's kind of like when, you ask somebody, what's a chemical property? Well, it's a property that's chemical. You didn't answer the question. All you did is chase yourself around in a circle, okay? So it's the amount of matter packed into something, how much space it takes up. Some objects are very dense. Very dense. Some objects are not so dense. Gases are not very dense. Why? Little bit of stuff packed into a lot of space, like the gases in this room. Other things are very dense. A lot of stuff packed into a little space. Today we're going to look at that in the lab. But today's lab is also about measurements. Since yesterday we learned how to take measurements, today we're going to see if you can actually take measurements properly. Okay? So that is what we are going to do. So what do we need to find density again? What two things?
Mass and volume.
We need mass and volume. Okay. How do we find mass, ladies and gentlemen? What do we use? We use a balance. Okay? I have one out at every lab station for you, ladies and gentlemen. They are sitting there waiting for you. You may have to turn them on when you get there. When you turn them on, wait till the balance reads 0.000, and then you can start taking masses on it. Okay? So you need the mass of something. We find that on a balance. What unit would that be in? Good. This is all also, ladies and gentlemen, a little bit of a review. Because on our test next week, Tuesday, I'm going to ask you about base units. Grams is a base unit, or mass is a base unit, measured in grams on a balance. Okay, good. So what else do we need to find density? What was the other thing we needed?
Volume.
We need volume. Okay? Now, there are a lot of ways of finding volume. In math, they teach you how to find the volume of just about any object. How do we find the volume of a rectangular shaped object? Length times width times height. Anybody know the volume of a circle? Me neither.
Yeah, it's 2D.
What?
It's 2D.
I'm sorry, a sphere. My bad. You're correct. Levi.
4/3 pi r cubed.
4/3 pi r cubed. Very good. How about a cylinder?
Wait, isn't it pi r squared times height?
Pi r squared times the height. Oh, you guys are good. Okay, here's the problem with those things. I hate measuring all that stuff. I really do.
Oh my god.
It's
It's already dead.
That's a dead
2%.
one.
Already dying.
You're joking. 3%? It just said 8%. Oh
Already
my
dying.
god.
What's that?
Can I get a charger too?
Yeah, I might
Really?
need one too.
Really, I cannot laugh at that today. I'm sorry.
This computer's nasty too. Like, you see that?
They
And
just
then,
don't
like,
like you.
this sticker is like falling off.
Computers
This is
just don't
clearly
like
not
you.
a new computer. I don't know why she was like, this is new. It's completely
You know,
new.
I find this humorous because,
Computers just don't like you.
again, the librarian called this morning to say, come and get this computer. Now, you would think that if you're coming to get a computer for the day, first thing in the morning,
It's charged.
it would be
Yeah.
charged.
Oh, it's at 2% now.
Oh, here you go.
Yeah.
Go for this. Okay.
It
Um,
went from 8% to 2%
again,
in like 3 seconds.
I find that humorous. Well,
Oh,
and
it's at 1%.
holy cow, it's fading fast.
Yeah.
Okay.
I don't know. What's
Okay, sorry. In math, there is a formula for just about any shape there is out there, ladies and gentlemen. There's a formula for just about any shape. You could look them up online, but that's a pain in the butt. How do we find volume in science?
Yeah, you can use liquid displacement.
Okay, we use a volume by displacement or liquid displacement method, okay? So there are 5 objects that you are going to find the density of today. One is a blue liquid, which is simply blue water.
Okay.
Still want you to find the density of it, okay? So that means you need to find the what and the what? Mass and volume. Please do not pour this on my balance and think you're going to find the mass of the liquid by pouring it on my balance. Okay? You have to have this in some sort of what?
Yeah.
Container. But remember, to find the volume or to find the density of the liquid,
You need to have the container material.
we only want the mass of the object inside, the liquid inside, and we only want the volume of that object as well, whatever it is. So again, you're going to have to find a way to find the mass of this for just the liquid, not the liquid in the container. Okay? This is another object that we're going to do. It's a plastic rod. Okay? Rod meaning it's round. Okay? And we will again be able to find the mass by putting it on the balance, not a problem. Okay? You don't even need to put this in anything. Okay? Solid object, put it on the balance, find the mass of it. Okay? There is a metal block there as well. Okay? Rectangular shaped metal block. We can find the volume of it and the mass by putting it on the balance. We got a cork for you, ladies and gentlemen. That may present some special problems. Hopefully you will understand how to take care of them when you face them. If not, I guess you're going to have to ask me. And then this is the gray metal object. Okay? That's how it's listed in your lab, as a gray metal object. Okay? Now, again, this one would be pretty difficult to find with a mathematical formula. I'm sure there is a formula for a pyramid out there, but it would be a little bit more difficult. So this is actually the easier way. But this is the one that creates a problem for us when we find the volume by displacement. We'll talk about that in just a minute, ladies and gentlemen. So, okay, I should have told you this, but let's open up your lab, ladies and gentlemen. Jared, go ahead and go get your computer. Okay, so in Google Classroom, ladies and gentlemen, the density lab is at the top. Please open it up and take a look at it, and it looks like this, ladies and gentlemen. Okay, by the way, I did grade your labs this morning. I put them into the grade book. I do not grade a lab unless it is turned in to me. So again, I had a few people this morning walk in and say, oh, I forgot to turn it in. Great, turn it in. I will get it graded. Okay. But again, when I'm going through them, some of you have your stuff in the lab and I can see it, but I don't know if you're done yet. So I don't grade it until you hit the turn in button. So please turn it in if you didn't turn it in yesterday. Okay. All right. You'll be finding the density of objects and comparing them to known values. So remember when we were talking about accuracy the other day? Accuracy, you can compare a value that you get to a known value. We are going to be doing that in this lab as well. So again, tying that in as well. So we're tying in precision, we're tying in observations, we're tying in accuracy, all of those things going into today's lab. So the purpose of today's lab is, hang on, I like red color better, to find the density of various objects parenthesis, making proper measurements. So that is what we did yesterday. We talked about how when you get an instrument, we report to a certain place because of the precision of the instrument. Practicing that again today. Digital balance is very easy. Why?
You don't have to estimate.
You don't have to estimate. You just have to write down the number that is there. But again, please, don't take something that ends in 0, 0 and drop the zeros. Because now you are changing the precision of the instrument. You are changing the number of sig figs in your calculation. Don't do any of that. So to find the density of various objects making proper measurements and compare them to the known values. In other words, after we find the density of each one of these objects, from the cork all the way to the blue liquid, I then have the known values in this lab for you. What you should have gotten. Now, what you get and what you should have gotten should be fairly close. That doesn't mean it's always going to be perfect, though. Okay? So don't panic if your numbers are a little bit off. But if the density is supposed to be 0.888 and you came up with 17.6, you got a problem there. You're off by a mile. Okay? So keep that in mind, ladies and gentlemen. Okay? All right. So that is what we are going to be doing. I always do the lab in a 2-column format. So you have procedure and you have observations. So find the mass of an object by using a balance or mass by difference method. What is by difference method? Okay, and why would we do that? Okay. So when we put the liquid on the balance, we don't want the mass of the container it's in, right? So we have to find the mass of some container, put the liquid in it, and then find the mass of the container in the liquid. That is by difference. By the way, that is exactly how we're going to find the what of most of these objects. Not the mass, but the volume. Most of the time we do volume by difference. Here's the volume without the object in there. Drop the object in there, the volume goes up. We can find the volume of the object then, okay? So we do this method a lot. It's just that if we're doing something on the balance that we can't put directly on the balance, a powdered substance, a liquid, things like that, then we have to do mass by difference. And there are various ways that you can do this, ladies and gentlemen. You just got to figure out how you're going to do it in the lab, okay? You're going to find the volume of an object. You can cross off this one. We're not going to do length times width times height. We're not going to, I don't even have rulers out there for you. We're going to do volume by displacement, okay? We're going to do volume by displacement. Then you're going to calculate the density of each object and compare it to the known values. Man, I did forget one step, which is you're going to also take qualitative observations. So up here in this table, you are going to take qualitative observations. The minimum required is 3. Now, there is nothing here that you cannot smell, nothing here that you cannot touch, nothing here that you cannot observe. Please don't lick anything because these things have been used multiple times in the past and I don't know what's on them, okay? And in reality, none of them should be talking to you, so please don't write down what you hear, okay? Keep the voices in your head to yourself, okay? So, you have other ways of doing these. Again, I have 4 spots there. You only need to fill 3 out of the 4, okay? For the gray metal object, for the block, for the liquid, for the rod, and for the cork. Now, again, rod is round, block is rectangular, just so that we're clear. And this is the gray metal object, okay? Now, after the qualitative observations, there is a table here for your quantitative observations, okay? Sorry, I change it from year to year. I updated everything else. I forgot to change that. Please change that to blue liquid, unless you have some yellow food coloring and you want to throw it in there, and then we could make green, but I don't have any with me right now. What's that?
I don't know if
You know, I forgot it this morning. I always do though.
Yeah.
You always forget it?
No, I always bring my yellow food coloring with me.
Yeah,
Okay.
don't you
Just in case of
bring around
emergency.
food coloring one, man?
I do because I like colorful food.
I like to bring a different color each time.
Do you?
Yeah.
Okay. So today was transparent.
Yeah.
Okay.
I didn't choose yellow today.
What'd you choose?
Stressful morning.
What do you got?
I chose not to pick it up today. You gotta
Today
get
was
a break.
actually
You gotta get a break throughout the week.
Well, it is a little after midweek. You're taking your midweek break. I completely understand. Completely understand.
Red is
How do we get off on such tangents in this class?
red is my favorite. It's the best.
What's your favorite color?
Red. It's
Then why aren't you wearing any red?
I love
it's
red.
close enough.
It's close enough. That is burnt orange sienna. Don't give me that that's red. Anyway, ladies and gentlemen.
It's orange. What the heck?
Hey, you put more terms and it sounds like you know what you're talking about. Okay?
It's not true.
So blue liquid. Okay. By the way, why do none of these we have mass by difference except for the liquid? Well, because the liquid's the only one where we have to worry about it because the liquid's the only one we cannot directly put on the balance. The other ones we can. So you may need to find the mass of something, put the liquid in it, find the mass of the liquid and that object together, and then subtract them. If you could find it another way, you are welcome to do that.
I don't like that you're actually correct.
Actually, what? Oh, I was right on the
That's the
color.
color, yeah.
Burnt orange sienna?
Yeah.
Hey, I'm not working out of the box of 8 crayons all the time. Okay.
Yeah.
But who knows if your display is set properly to where you're getting the proper imaging. But anyway, down here, ladies and gentlemen, we're going to do volume by displacement. And again, I know you know how to do this, but I want to go over it real quick. Okay, when you put water into the graduated cylinder, the important part is that you put in enough water that you completely submerge the object. The object has to be completely under the water. So sometimes people will put in a small amount of water, drop the object in there, and it will not be covered. That cannot work. You need the object to be completely underwater to find the volume of the entire object. Now, because we're working with 100 milliliter graduated cylinders, I would put in anywhere from 40 to 50. Because none of these objects are big enough to overflow at that. Because that's the other thing that my freshmen do is they'll put in like 95 milliliters of water, put the object in, and their water level will be up here. And they're like, Mr. Brand, what do I do now? Well, you start over again because you messed up. Okay? You start over again because you messed up. So put about 50 in. Now, it's real important, ladies and gentlemen, that when you put your water in there, you know how much you're putting in there. I don't care how much you're putting in there. You could put in 47.2 milliliters if you want. Matters not to me. But you need to know exactly what you're putting in. And if you're a person who always needs the bigger number on top and then subtracting by the littler number, put the volume that you're putting in the cylinder down in here then, ladies and gentlemen, because when you put the object in, it's going to go up, correct? Okay? So then you'll have the object with the volume with the object in it minus the volume without the object in it. That will give you the volume of the object. Okay? Now, again, I know you know this, but a couple things for safety. When you are doing this, after I have my volume, when you go to put the object in, please hold this on the side. Please put this in here, and please let it gently slide down into the bottom. Couple of reasons. Number one, we don't want water spilling out all over the place, but more importantly, number two, we don't want to shatter out the bottom of our graduated cylinder. And this object will do that. If you hold this up here and drop it, it will go right straight through down onto the table. So when you put this object in, it's real important that you put it in at the side and try to let it gently go down there as much as possible. Find out how much the water level went up. Mark it down. Subtract these two. That will give you the final volume of the object that is inside here. Okay? Now, what do you notice about the volume by displacement? In mass by difference, 4 out of 5 were blacked out. Why is one blacked out in the bottom? You can't put a liquid into another liquid and find the volume of just the liquid that you put in there. But luckily, what does this instrument measure? The volume. Just put it in there. However much you found the mass of, put it in here and you will find the volume of the liquid. Okay? We don't need to do volume by difference for a liquid because we can just measure it. When you're done, go over to the sink, ladies and gentlemen. Take and dump out the water in the sink. Don't put it back into the containers. Okay? Catch the object. Most of the sinks have a bottom that the object will not go down into. But please catch the object anyway. Take and dry it off. Put it back because at each station there are these 5 objects for the 2 groups on both sides to share. So while they're working with one object, you can be working with another, but you've also got to share the balance, ladies and gentlemen. So I'm sure you will find a way to do that. Okay? Now, again, collect all of this information. Get all of this collected. The only thing I need, though, here is mass and volume. I have to do these to find the volume, but the only thing I need here is volume. Okay? Then what you are going to do, ladies and gentlemen, is you're going to come down here to this table. And in this table, ladies and gentlemen, we are going to find density by taking mass divided by volume. So you have the mass of the gray metal object, you have the volume of it, divide the two, and in here, give me what the density is. Now, this is the density that we should get. This is the known density of that gray metal object. This is the known density of that block, that metal block. There's the density of your liquid. Here's the density of the rod. The density of the cork varies a little bit. It's not one that you can have an exact number, so we give you the range that you would find for most cork. Okay? So you're going to find all of your densities here, ladies and gentlemen. Okay? And then there are a few questions and a conclusion to write. Okay? So why is it necessary to find the mass by difference for some objects? I think we've covered that pretty well. Why is it necessary to find volume by displacement for some objects? Again, I'm not saying you couldn't do these mathematically, but to me, finding the length times the width times the height of this is not as easy as dropping it into a container and just measuring one thing. That's my opinion on it, ladies and gentlemen. Okay? Number 3, what kind of observations should be reproducible and why? You made quantitative and qualitative in this lab. Which kind are reproducible? Okay, and why is that so? And then, ladies and gentlemen, in the bottom, you are going to compare the calculated densities to the known densities of all 5 objects. Okay? You're going to tell how these densities compare to each other in the lab, and data must be included. So you're going to tell me for the gray metal object, I was a little bit below the known density, or a little bit above, or I was way off. And again, I'm not judging you on how well you do the lab, but I also don't want you lying to me in your conclusion. If you feel your densities were far off, please say it. If you feel your densities were close, go ahead and say it. But somewhere in here, you've got to talk about all 5 objects. And somewhere in here, you have to put some numbers. So you could do one, for example, my closest one was when I found the density of this to be 3.11 and the known density was 3.10. Something like that. Okay? Questions? All right. Everything is back in the lab, ladies and gentlemen. Because we only have, there's less than 20 of us in here, we don't need this lab station over here right behind Jen. Okay? So that lab station is not needed. And I only have one set up at this station here. Every other station has 2 setups at it. Okay? Again, please partner up. Please get with somebody. Please work on the lab and get it done, ladies and gentlemen. Let me check here. 2, 4, 6, 8, 10, 12, 14, 16. So that should be 8 groups of 2. No one should be working alone. So get with your partners and go to work, ladies and gentlemen. Let's go. Let's go. Let's go. Yes.
Sorry, I didn't do that.
Oh.
I just
You-
Am I?
Maybe do that. I was like,
This is like.
Sure.
Oh
Do you know who you're working with? Okay, that's fine then. Go ahead. I just want to make sure you know first. Brindley.
I'll just but
Excuse me. I think I'm starting to run out of these. But that's okay because you know when they gave these to us? No, during COVID. So that's how long I've had these.
Oh, way back.
I wasn't even born in 1955.
Are you sure?
Yeah.
This school's pretty long.
I'm pretty positive, Brindley. I know when I was born.
You can never be too sure.
Yes, I can. I have a birth certificate and everything. Now, granted, it's carved into stone, but I still have one.
Carved into stone. Why would somebody have their birth certificate?
Really?
I think
Like
that
a-
old.
That's an age joke. Old people, they didn't have paper back then,
Well, I'm not old.
so they would carve things into stone.
Okay, I guess this tape is just like stuck on here forever. You just have to be
yeah.
What kind of tape?
I don't know. Someone put like
I mean,
mega
I guess
adhesive
it has
tape
color.
on it. Also, this like touchpad is bad. Sorry, I have a lot to complain about.
Ah.
It's the right.
It's okay. I'm used to people complaining. I'm married. Follow him. Come on in. Hey, what are you working? Morning. Aiden, did you come from student services or something, or? Okay, I'll end your pass. Please share nicely with the group next to you. Hold it slowly. Water level goes up. Don't stop flowing. And drop. That's a hot plate. Use that. We're not heating anything today. Okay, good. Go with that. Yes. So for that, we're going to need to play the mass. So here, we're doing the walk. Okay. So down here. I would put the one on the top. It doesn't matter. Here's the okay, relief comes back. If you ever need to fill up your pitchers with water, ladies and gentlemen, there are 4 jugs. 2 over here, 2 over there. You can fill it up if you need to, or call me over and I will fill it up for you. Look at this. Because but also when we get to the worst point, we only do anything over like 80, 97. Questions? volume. Now, here's the thing. You did the volume of that. So just make it whoops. It's okay. It's okay. What wrong? Okay. Did it fall in there? Okay. $3. I'm in the ring. But it does make for a good point, which is try to keep yourself like in the middle of the table to where it won't accident. Over. Please, we got a question for you. When you found the mass of the blue liquid, find its volume? We need to do that one. You gotta have the volume of the mass you found. So you can do that. Well, yeah, remember, by volume, just read one level. It all. Yes. If your volume is enough for the here. So, yes.
Just don't.
Should I do it?
There's no way. Well, at least you figured out. Hopefully, you're not better at this. Okay, how are you doing?
Now you lost the water.
Almost another very different things. All of your masses will be the 4 or 5 centimeters. But dense volume cell. So after the limit of 6 weeks, divide how many 6 weeks for each something. If you divide something to 4 6 weeks by something to 2, you can only put 2 in the context. Okay? If you divide something by 4 6 weeks by something to 3, our sections, please, even though we're using the same instrument, our sections unchanged.
Okay. Okay, wait.
The lab is not due till tomorrow, ladies and gentlemen, so I will give you some time tomorrow to work on it as well. Okay?
Okay, we got a lot. Yeah, let's go boring.
I don't like.
Make sure my calculators get back, please, ladies and gentlemen. Again, I don't expect the lab to be turned in tonight. If you have questions tomorrow, I will answer them for you. We will get them done tomorrow in class.
What is this class?
Not even inside.
Because I don't have time.
Oh yeah. And they're also last time.
ladies and gentlemen. Make sure my calculators get back and my chargers get back if you have one of mine. We will see you on Friday, ladies and gentlemen.
I don't know where that was.
Perfect.